Hey, what's up guys? Welcome back to the channel. So I'm here with another interesting problem, which is longest increasing subsequence. Guys, this problem is again a standard DSA problem and is generally solved using the dynamic programming approach, where we come up with a solution which has the time complexity of O of n square. Here n is the size of the array, right? Now guys, we have another interesting solution which has the time complexity of O of n log n, and in this video I am going to cover this particular solution only. So if you guys are fearing that this solution may have dynamic programming as the prerequisite, then you need not to worry, because this solution has a completely different intuition, approach and the implementation. So guys, believe me, if you watch this video till the end, then you will have a complete idea about how we can solve this problem in just O of n log n time complexity, right? So guys, now let me start right away from the problem statement. It says that you are given an array of integers and your task is to find the length of the longest increasing subsequence from the given array. First of all, let me start with what exactly is a subsequence. So I'm going to take an example. Let's say I have an array which contains element 1, 3, 2, then 4, then 2, right? Guys, from this array, I can take any subsequence. So subsequence is basically a set of characters that we pick from this array while maintaining the order of elements. So I can pick this 1, I can pick this 2, and I can pick this 4, right? So I have 1, 2, 4 as one of the subsequence. Or I can pick the continuous element as well, like I can pick 1, 3, 2. So 1, 3, 2 is another subsequence of this array. After this we have single element as well, one of the subsequences, right? Or I can choose the whole array as the subsequence. So 1, 3, 2, 4, 2 is again one of the possible subsequences of this particular array, right? Guys, this is about the subsequence, and while writing subsequence we have to maintain the order of elements. Like I can't write any element by 4 then 2 then 1, right? Because this is not a valid subsequence, this is not following the order of elements, right? So I have to maintain the order as well. Now, talking about what exactly is a strictly increasing subsequence, so first of all let me remove this, guys. Okay, so from this array, I can write some increasing subsequences which has increasing order of elements. So I have 1, then 2, then 2, right? 1, 2, 2 is a increasing subsequence, or I have 1, then 2, then 4, right? So both of these are increasing subsequence. But one thing we can observe, that this subsequence contains equal elements, right? So it's not an strictly increasing, but this particular subsequence is a strictly increasing subsequence. So this is about strictly increasing, right? We should not have any equal elements in the strictly increasing subsequence. Now guys, problem says that we are given an array and we have to find the length of longest increasing subsequence. So guys, we are given this example. I'm going to solve this example. First of all, let me remove this stuff from the page. Okay guys, so see, for this example I can choose a subsequence where I have element 0, then I can choose 2, then I can choose this 6, then 9. After this I can choose this 13 and this 15, right? So what is the subsequence that we have? We have 0, 2, 6, 9, then 13 and 15. So guys, this is the longest subsequence possible in this particular array with a length of 6. And there are multiple subsequences which has the same length, like I can choose 0, then 4, then 6, then 9, then 11 and 15, right? This is again one of the possible subsequences, but the length is 6, right? And we are concerned about length, so we don't care how many subsequences we have. All we need to do is we just need to return 6 as the output. Now guys, I hope you have understood the problem statement well. So let's talk about the solution now. Okay, so I have written one example here, and guys, I'm going to use this particular example in order to explain you the intuition and the approach. The first question that I want to ask from you is, as a beginner guys, how you are going to try to approach this particular example. For now, just forget about the whole problem that we have. I'm talking about this particular example only, guys. How as a beginner you are going to approach this example? Let me tell you how I will try to approach it. So guys, I'll start right away from the first element at I equals to 0, right? And the question that I'll ask from myself is, till this point, what is the longest increasing subsequence that I have? So first of all, let me remove this, guys. Okay, so the first question that I'll ask is, till this point, what is the longest increasing subsequence that I have? So we'll say that, hey, the answer is quite easy. We have only single element, right? So the longest increasing subsequence is going to be 5 only, and the length is going to be 1, right? This is about I equals to 0. This is about I equals to 0. After this I will move to the next element, and now I have I equals to 1, and again I have the same question, that till this point, what is the longest increasing subsequence that I have? Now I have two elements, right? So guys, I'm simply going to compare this particular element with the last of this list, because if this element is greater, so I can simply append this element to the last of this list, right? I can simply write 8 here. Why I can write? Because I need an increasing subsequence, right? So I will compare this 8 with the last of this particular list, and if 8 is greater, you can see that even 8 is greater, right? So I can append this 8 to the end of this list. So what I'll do is, first of all, let me write the list here. I have 5, right? So I can append 8 to the end of 5. But hold on. Before I append, I want to make a copy of this list. So I'll make a copy, and now I will append 8 here. Why I'm making the copy? Because let's say somewhere I have 6, right? For this array we don't have 6, but let's say we have 6 somewhere. So you can see that I can append 6 here, guys, right? So that's why I'm taking a copy and then I'm appending the element, right? So guys, now I will come to the third element, which is here, right? So first of all, let me remove this. And now I'm at the third element where I equals to 2. And guys, again the same question, what is the longest increasing subsequence till this point? What is the longest increasing subsequence? So again, I will compare this element with the end of these two lists. So let me write the end elements here. I have 5 and 8, right? These are the end elements. So again, I will do the same thing. I will compare this 4 with the end elements. So you can see that 4 is something which is smaller than both the end elements, right? So at this point, guys, I am going to start a new list from 4. So first of all, let me write these stuff. I have 5, then I have second list 5 and 8, right? Guys, in this point, I'm going to start a new list. So this list is going to be a single element 4, right? Because you can see that I cannot append 4 to any list. Now I want you to observe something very important, guys, from this. See, if I have any element, let's say I have element 5. So you can see that I can append 5 at the end of this list, but I cannot append 5 at the end of this particular list, because this is not going to give me an strictly increasing subsequence, right? And any element greater than 5 I can append to end of this particular list only. So this means that I can simply discard this list. Let me explain this particular thing in detail. So guys, I have two lists. One is single element 4, then I have single element 5, right? Let's say I want to append two element at the end of these two lists. So I have 5 and 6, right? So guys, I'll start with 5. You can see that I cannot append 5 here, because this is not something which will give me a strictly increasing subsequence, because guys, we don't have equal element in strictly increasing subsequence. So I can append 5 here, but I cannot append here. After this, I'll come to 6. I can append 6 here and here as well, because 6 is greater, right? So guys, now I'm done with both the elements, and you can see that this list is something which is longer increasing subsequence than this particular list, right? What is the reason, guys? Because this list is starting from a smaller element, right? So this is the reason. And one more thing is, whenever we have a list whose end element is smaller than other list, guys, so that particular list has a more potential of giving the longer increasing subsequence. Always remember this rule, guys. So that's why I can simply discard this particular list, right? Now I have only two lists. One list is ending with 4 and the second list is ending with 8, right? After this, guys, I'll simply come to this particular element I, and again the same question, what is the longest increasing subsequence till this point? So guys, see, at this point again I will compare this particular element 12 with the end of this particular list, right? So guys, end element are 4 and 8, and you can see that 12 is greater than both of these elements, right? So I can append 12 to end of any list, but I will prefer to append at the end of this particular list, because this is greater. And if I append at the end of this list, so I will get a more greater list, right? So guys, I can do it. I'll simply write first list that I have 4. After this I have 5, 8, right? So I can append 12 here, but I will make a copy first. So I'll make a copy which is 5, 8, and after this I will write 12. So guys, now you can see that till this point I have 3 lists, and all these are increasing list. And guys, strictly increasing list, all these are strictly increasing, and this is the longest increasing subsequence that I have, which is 5, 8, 12, right? This is till this particular point, guys. And what are the end elements? Let me write the end elements as well. I have 4, then 8, then 12. This is till this particular point. After this I will come to this point, and again the same question, guys, what is the longest increasing subsequence till this point? So see, this 2 is something which is smaller than all the elements, right? So like we have done in this particular iteration, we can again start a new list. So I'll start a new list from 2, then I have list 4 as well, then I have 5 comma 8, then I have 5 comma 8 comma 12. And if you think we are going to discard this list, then you are right, bro. The reason is, see, this particular list is, again you can see that starting from a greater element, right? And this list is starting from a smaller element, so of course we are going to consider this particular list. After this, guys, I will come to this particular point, and okay, let me write the end elements as well. I have 2 as the end element, then I have 4 is discarded now, then I have 8, and then I have 12, right? After this I come to this 10. Now see guys, this 10 is something that cannot be appended to the end of this list and end of this particular list, right? Okay, 10 can be appended to end of this particular list and this particular list as well. There are two lists, right? Two candidate list for appending value 10, right? But I'm going to choose this particular list, right? What is the reason? The reason is this list is of greater length, right? So guys, I'm going to append to this particular list, and I will have 2, then I will have 5 comma 8, then I will have a copy of this, right? 5 comma 8, and then I will append 10. After this I have 5 and 8 and 12. Again you can see that guys, we have two lists of same length, right? We have two lists of same length, so we are going to discard one of them. And which one to discard? Of course you can see that this list contains the greater last element, so it has less potential of giving the longer increasing subsequence, right? And this list has the more potential. Again the same concept we are going to use. So guys, I will simply discard this list, and till this 10 I have 3 list, which is 2, then I have, okay, 5 8, then I have 5 8 10, right? And the ending elements are 2 8 and 10. After this guys, I have the last iteration, so let me show you last iteration. Okay, here let me show you the last iteration here. So see, I have the element 14 and these are the lists that I have till now. So guys, 14 is greater than all these lists. If I compare with the end elements, I will simply append this 14 as the at the end of this particular list, right? This is the same thing which we have done when we were at 12, right? So after this guys, you can see that what is the list that I have. I have 2, then I have 5 comma 8, then I have 5 comma 8 comma 10. I can append 14, but before that I need to make a copy. So I'll make a copy 5 8 10, and now I can append 14, right? Now guys, this is the answer that we have. Till this point, or in the whole array, we have 4 increasing subsequence, out of which this is the longest increasing subsequence, right? So guys, 4 is going to be the answer for this particular example. And now I hope this will make the idea clear to you what we are actually going to do, guys. See, what we are doing here is we are going to make 3 observations from this particular dry run. See, the first observation says that if AI is basically the element of the array that we have, right? The ith element of the array. If AI is smallest among all the and candidates of active list. What are the active list? Active list are basically these lists that I am keeping track of, right? And guys, all these are active list. And now one more thing is I'm comparing with end elements only, right? I have 2 8 then 10 then 14. You can see here that I am comparing the current element with end elements only, and if it is smaller than all the end elements, like for this particular example guys, you can see that we have list 5 and 5 8, right? And 4 was smaller than both of the end elements which we have, which were 5 and 8. So we started a new list, right? So at this point we need to start a new list which has the length 1. Obviously the length is going to be 1 if we are starting a new list of single element, right? After this, the second rule says that if AI is largest among all and candidates of active list, then we will clone the largest active list and we will extend it by AI. Okay, see guys, uh, it says that if AI is largest among all the candidates, you can see that for this particular example, last iteration, these are the AND candidates that I have, and 14 is greater than all the AND candidates that we have, right? So in that particular case, we will simply clone the largest list that we have, 5 8 10, right? We will simply clone it and we will append the element at the end of that particular list, right? And this way we are able to get the longest list that we have, right? After this, what is the third rule? The third rule is if AI is in between. What does this mean? This basically means that if AI, let's say for this particular case, right, we have this particular example. So 10 was between 2 and 12, right? We have all the end values, and 10 is something which is somewhere between 2 and 12, right? So at this point, right, at this point guys, what we need to do is we need to find a list with the largest end element that is smaller than AI. So AI is equal to 10, and what is the largest element which is smaller than AI? So 8 is the largest end element which is smaller than 10, right, which is smaller than 10 AI. So we will simply append 10 to the end of this particular list, right? So guys, this is what we have done here. You can see that we have done 5 8 10. After that we discarded this list. So you can see that we will discard all other list of same length as that of this modified list, guys. This is all we need to observe. We have made three main observations. After this, we can make one more observation. And I have already told you that I'm only comparing the array element with the end elements only, right? So guys, while writing the solution, we are just going to keep track of end element only, and we will not be concerned about these element, right? After this, whatever is the length of this particular end element array, so let's say I store all the end element in an array. So let's say this is end array. So guys, I just need to return the length of this array, because you can see that for four element I have four different like active list. Why I have four different active lists? Because I have a unique active list for each length, for length 1, for length 2, for length 3, and for length 4, right? So guys, whatever is the length of this end array is going to be my answer, right? Now we are going to try to implement this particular approach, guys. Let me explain how we will implement this. Okay, so I have written the same example here, and guys, whatever we have figured out till now, we are going to convert those observations into code, and our task is done. I just want you to listen carefully, because implementation is bit tricky to understand. Writing from okay, starting from the first observation. So guys, see, for each element AI, we are comparing that particular element with the end element of the active list only. See, for I equals to 6. For I equals to 6, we are pointing to this element 14, right? And guys, we have three active list, and what are the end elements? So 2, 8, and 10 are the end elements, and we are comparing this 14 with these end elements only, right? So guys, this is the first observation. This means that we need an AND array, this which is going to keep track of end elements of the active list only, so we don't need to keep track of the whole active list, right? So this is the AND array. Initially the size is going to be 0, right? And guys, see, I start from I equals to 0, and for I equals to 0 I have a single list, like single longest increasing subsequence for I equals to 0, which is this one, right? And what is the last element? This is 5. So I have to initialize my AND array with element 5, right? And this is going to be the first value in the AND array. After this, I will start from I equals to 1, and then I'll simply move till the end of the array. So let me write a loop here. I have 4. Okay, let me remove this, guys. Let me remove this. I'll write 4, I equals to 1, then I smaller than n, then I plus plus, right? After this, my size is not 0 now. My size is 1, because you can see that I have appended 5 at the end of this particular end list, right? After this, guys, see, we have three observations for each element AI and the end element of the active list. There are three cases possible. Let me explain all these. So the first case is if AI is smallest among all the end candidates of the active list, if AI is largest among all the end candidates of the active list, right? And if AI is in between. So you can see here that we have all the end elements in the end array. So if AI, which is let's say this 8, is greater than all the values in the end array, right? In that particular case, what we need to do? So guys, what we were doing in dry run, you can see that we were replicating the list. So let me explain what we were doing. When I was at this particular point, then what were the list? The list after this particular iteration was I have 2, then I have 5 comma 8, then I have 5, 8, and 10, isn't it, guys? So we have three lists. When we pass through this particular element, after this we come to this element, and we compare the end elements which were 2, 8, and 10 of this particular three active list with this value, right? And you can see that this 14 is greater than all these values. How I can compare? I can simply compare with the last value, as I have the sorted list. So if this AI is greater than the last value, then this is greater than all the values in the end list, right? So let me write this, guys. I'm simply going to write if AI is greater than the end value of the end list, right? So what is the last value in the end list? The last value I can simply figure out by uh, end of size minus 1, right? We have a size variable for size. So size minus 1, this is how I can check the last value, right? And guys, if this value is something, if AI is something which is greater than this value, in that particular case, what we need to do? We need to replicate this particular list, right? So I'll write 2, then 5, 8, then I have 5, 8, 10, then I will again replicate this list. I have 5, 8, 10 again, and after this I will append 14 to the end of this list. This way I am able to get 2, 8, 10, and 14, right? You can see that all these lists or all these values are unchanged, right? We have only introduced a new value, which is 14, which is the new end value. So I can simply append the current element to the end of this list. I hope now you have understood this, guys. I can simply append n dot append the last element, which is the current element. I'll say that AI, right? So guys, this way I will have 8 here now. This is for the second iteration that we have, and like this we are going to move again and again, right? You can even see that for the like second iteration, what were the active list when we completed this iteration? We have 5 as the first active list, then we have 5 8, right? So guys, and element are going to be 5 8 only, so you can see that we are moving in the right direction, right? After this, we have handled one case. We have handled one case, which is this particular case, right? Which is the second case. And now we are going to cover the first and third case in one condition only. This is very interesting, I see. uh, I will simply write an else case. Else, there are two things. First one is if AI is something which is smaller than all the values, and second condition is if AI is something in between. So see guys, let me start with the smaller value first, right? So for the smaller value, you can see that like for this till this point, guys, what were the list we have? First of all, let me remove this. I will explain everything with examples so that it will get more clear to you, right? Let me remove this, guys. So before we come to this particular point, the active list that we have was 5, then 5 8. Okay, my bad, I have 4 here, right? So I have 4, then 5 8, then 5 8, 5 8 12, right? These are the three active lists. Now when I see 2, so what I do is, first of all, let me write the AND element as well. I have 4 8 and 12. This is AND array for this particular three active list. So when I see this 2, guys, this 2 is something smaller than all the elements, right? So at this point, I will simply find the first value which is greater than this 2, right? I'll find the first value which is greater than this 2, and I will simply replace that particular value with 2. So this way I'm able to get 2 8 12. And even if you see the dry run, then what we have done was we have introduced a new list which is 2, and then we have 4, then we have 5 8, then we have 5 8 and 12, and then we discarded this 4, right? So guys, this is simply meaning that I am simply replacing this 4 with this 2, right? So can I write 2 here instead of 4? Both means the same. So I will simply find the first index. I'll simply find the first index. Let me write here first index, first index with value greater than greater than uh, greater than AI. My handwriting is not good, guys, but that's why I'm saying and then writing, right? So guys, I'll simply find the first value which is greater than AI, and then I'll simply replace and of that particular that particular index in the AND array with the current AI, right? So I'll write AND of index equals to AI, right? And this index basically comes from this particular thing, whatever we are going to do here, right? So guys, this is about the second case when the element is smaller than all the element, right? We have one more case where the element is in between. So in that particular case as well, we are going to do the same thing. You can see that for 10, we have 10 between 2 and 12, right? So guys, for this, you can see that we are looking for the first element which is smaller than 10. So this element is something which is smaller than 10. So I'll simply replace this particular, okay, we'll simply look for the first element which is greater than 10. This is the element. You can see that we are looking for the first element greater, right? And we'll simply replace this 12 with 10, and this way we are able to get 2 8 and 10. And guys, you can see that after this iteration, this was the thing that we have 2 8 10, right? So guys, now I hope the idea is clear to you, right? So that's how this condition is going to handle all the other cases, right? And this is all we need to do, guys. Let me explain how we are going to do this particular thing, like finding the index with value just greater than AI, right? Finding the first index. I'm going to remove this, and guys, let's say we have an array, and if we have to find the first index which is just greater than the given element AI, then this is something known as lower bound of an array. Lower bound of an array. And guys, if we have a sorted array, then this task becomes even more easier. We just need to run a binary search over the array and we can do our task, right? I will explain this particular thing in detail, but for now we have to observe one thing, that this particular array is a sorted array, right? Even you can see here, guys, because we have sorted list, and the last of this list is always the last of this particular list is always smaller than the last of second list, right? So this way I'm always going to have a sorted AND list. So guys, whenever we have a sorted list, then we can simply use binary search in order to do this particular task, right? So I hope you have understood this particular code. Now I will talk about how we can find the lower bound of an array. I have written the title here as well. Okay, so there is an example, guys. Let's say I have this particular array and I want to find the lower bound of the element 4. So how I can find, guys? See, binary search basically says that we start from the like search space, which is equal to the whole array size itself, right? This is 0 and this is n minus 1. After this, we keep reducing the search space of the array, and this way we are able to search optimally. We have to look for the first element which is greater than 4. So how we are going to search? Let's say this is my low, so my low is basically equal to 0, and then we have high, which is equal to n minus 1. So first task is to find the mid element of this particular range. So I can simply find mid by doing low plus high by 2. High by 2, this is how I can get the mid element. So this is 0 1 2 3 4 5 6 7. So low is basically, high is basically equal to 7 and low is equal to 0. So 7 plus 0 by 2 is basically equal to 3, right? I'm talking about integer division here. So 0 1 2 3, this is the element, and you can see that, guys, mid element is something which is greater than this particular value, right? So can I say that this can be my answer? This is my potential answer. So I'll say that, okay, if my array of mid is something which is greater than or equal to, because I can find the element equal as well when I talk about lower bound, right? So guys, if my array of mid is greater than equal to my x, then I can write two things. First is my answer equals to mid, right? Because mid is my potential answer, but there is no guarantee that this is the answer. If this is greater, then there is also a possibility that greater element are on the left as well. Let's say I have 4 here, so you can see that I have a like greater element on the left side, right? So I'll simply move to the left side. I'll say that, okay, my high will become equal to mid minus 1, and this way I'm simply able to reduce my search space. Now I will search in this particular space, right? I'm simply going to discard all these values, and else if like this x is something which is greater, in that particular case, guys, I need to increase my values so that I can get greater values, right? So I'll say that else my low simply become equal to mid plus 1. This is how I can get the lower bound of any particular sorted array, right? And guys, I have to run this particular thing in loop while my low is something which is smaller than equal to high, right? So I have to do this particular task again and again. I'm just Guys, I'm just explaining this particular concept which is lower bound in brief only, because this is again a different concept, right? So I'm just giving the idea how it actually works. And guys, now my task is done. Like, I have explained everything about this solution. Now I'm just left with two things. The first one is code, and the second thing is time complexity and the space complexity, right? So let me start with the code first. Here is the code, guys. You can see that I have written the C++ code on the left hand side, then I have written the Python code, then Java code. So for the C++ code, this is the lower bound function. This is the lower bound function that we have, guys, and I'm using binary search to implement, right? We can do this with a linear search as well, but binary search is more optimal. After this, this is the main task that we are doing, guys. See, we are first this answer array is basically the end array to keep track of end element, right? After this, this is the task from I equals to 1 to n, and this is going to give me the whole answer at the last, right? At last, we just need to return the size of answer array, guys. I have already explained this thing to you, right? After this, we have lower bound function here as well in Python, and this is the main task, right? And this is the Java code, guys. Now I hope the code is also clear to you. So talking about the time complexity, guys, so see, we are running a loop from for I equals to 1 to n, right? And inside this we are doing a task which is going to find the lower bound. So this is log n complexity. Binary search takes O of log n time, right? And this is n time. So the total complexity is O of n log n. This is about the time complexity. And what about the space complexity? So I'm using some extra space in order to keep track of active list, right? So guys, O of n is going to be the space complexity for this particular approach. Now guys, I hope everything related to this problem is clear to you. This is about the optimal approach that we have, guys. Thank you.